Today, let's focus on evaluating a special definite integral. Let f(x) equals the integral from 0 to x 2 sine t over pi minus 2t dt. And we want to evaluate the integral from 0 to half pi fx dx. Before moving on, let's see the value of r at pi over 2. So we get 0 to pi over 2, 2 sine t over pi minus 2t dt. So we can break up the interval to two parts. So 0 to pi over 6, 2 sine t over pi minus 2t dt plus from pi over 6 to pi over 2. So get 2 sine t pi minus 2t dt. We know within the interval 0 to half pi, the integrand is positive. So then that means the first integral is positive. So we can get the conclusion that one greater than the second part. So be pi over 6 to pi over 2, 2 sine t over pi minus 2t dt. Now, in the interval pi over 6 to pi over 2, sine is increasing. So if we change sine t to sine pi over 6, pi minus 2t, you see, okay, so it's the pi over 6, pi over 2. You see we have the relation. Okay, now sine pi over 6 equals half. So this one equals pi over 6 over pi over 2. And then here is dt over pi minus 2t. And we know the antiderivative of this one equals negative half ln pi minus 2t. Evaluate pi over 2 and pi over 6. So we get negative half. When t equals half pi, we get ln 0. When t equals pi over 6, we got ln 2 pi over 3. So you see this part is negative infinity. So you see the outcome should be positive infinity. So I just erase this part. Okay, so get erase all of them. So you know that's positive infinity. Positive infinity. So we know that's positive infinity. Now, in order to evaluate the definite integral, we want to apply integration by parts. In order to do that, we need to change dx to dx minus half pi. So we get I equals integral from 0 pi over 2 of x dx minus pi over 2. And then you can view this part as u, this part as v. So using integration by parts, we know we get f(x) times x minus half pi, evaluate at pi over 2 and 0 minus integral from 0 to half pi v du. So we get x minus pi over 2 times df, which is r prime x dx. Now when x approach half pi, f(x) approach infinity, and this one approach 0. So we can only use the limit to express it. So x approach half pi from left side of x minus pi over 2. When x equals 0, we get of 0, and then here we get negative pi over 2. The last term, integral 0 to half pi x minus half pi. Because f equals this one, so applying fundamental theorem of calculus, we get f prime equals 2 sin x over pi minus 2x dx. Now we denote the first part as I1, second part as I2, the last part as I3. Let's look at I3. I3 equals integral from 0 to half pi. 2 times the first term, we get 2x minus pi. And then here we still have sin x over the bottom, pi minus 2x dx. Now we can cancel these, and then we get negative 1. So we get integral from 0 to pi over 2 negative sin x dx. We know the antiderivative of this one equals cosine. So we get cosine, the upper limit pi over 2, lower limit 0. So we get cosine pi over 2 minus cosine 0. So we get 0 minus 1 equals negative 1. Now let's look at I2. So I2 equals f0. So we get 0 to 0, 2 sin t over pi minus 2t dt times negative pi over 2. Because the integral is from 0 to 0, so you see the value should be 0. So 0 times negative pi over 2 equals 0. Now let's look at I1. I1 equals the limit when x approaches pi over 2 from left side. So we put fx on top, and x we will write as 0 to x. 2 sin t over pi minus 2t dt. And the second factor I write as 1 over x minus pi over 2. You see, when x approaches half pi from left side, the top approaches infinity, the bottom 1 over 0 also infinity. So this is indeterminate form. We can use L'Hopital's rule. So let's see. So limit x approach pi over 2 to left from left side. Take the derivative of the top, we get 2 sin x over pi minus 2x. The bottom, we get negative 1 over x minus pi over 2 squared. So we get the negative out. So limit x approach pi over 2 from left side. For the numerator, we divide 2 for top and bottom. So I get sin x. The bottom equal pi over 2 minus x. And then we multiply the reciprocal. At the same time, I change the order. So times pi over 2 minus x squared. Then I cancel one factor. So you see we get limit x approach pi over 2 from left side. The first factor is sin x. The second factor is pi over 2 minus x. We know the limit of sin x when x approaches half pi is 1, but the second factor is 0. So you see the outcome is 0. So we know the value of the definite integral I equals I1 minus I2 minus I3. And I1 equals 0, I2 0, I3 negative 1 equals 1. That is the value of the definite integral.